one can do it is using the Latiger-Tissa theorem. So basically, here is, so we will direction. Now we have three types of eigenmodes corresponding to x type of spins, x direction of spins, y direction of spins, and z direction of spins. And basically we have to look to the minimum of these eigenmodes, and one can immediately see that the minimum lines on the minimum sits on the lines in the K space, and basically what lines, these lines or that lines, depend on the sign of K2 interaction, because it depends on this K2. So basically K2 interaction, which actually couples with triangle lattice, I will talk about triangle points separately, determine the type of classical degeneracy of this mode. So degeneracy of the ground state is 3 because it can be 3 different lines, and 2 to the power L, where L is the number of ladders, because the ladders are formed by non-zero K1 interaction. And basically this degeneracy, classical degeneracy, is not accidental because it's related to the symmetry of the Hamiltonian, and the symmetry is sliding symmetry. In a moment I will just explain what is this symmetry, and it's kind of gauge-like symmetry, and therefore for classical spin at equals 0, this cannot be broken. Okay. So basically, let me construct, looking to this degenerate, let me construct one of the states. Let me satisfy all the z bonds. Basically, I will be looking to the minimum of lambda z eigenmodes. So in this plot, so my z bond, nearest neighbor z bond, is my vertical bond, and my next nearest neighbor z bond is my horizontal bond. So I consider both coupling ferromagnetic, K1 and K2, and basically I'm satisfying all these bonds. So I satisfy all the bonds on the nearest neighbor, and I satisfy all the bonds for the second neighbor. But because spins are classical, so the interaction, the coupling between these ladders are by x and y bonds, and basically for classical spins this gives no coupling. And therefore I have a symmetry. Basically I can take any of these ladders and I can flip it, and the energy of the Hamiltonian will be the same. So I can flip all the yellow ladders and get the ferromagnetic state, which will also be the classical ground state, or I can take just one yellow ladder, flip it, and will be also ground state. So basically all the points laying on these QZ vectors, these horizontal vectors, will correspond to the classical ground state. So the classical order is nematic-like, but at t equals 0, it's all these states with ladders in z direction, x direction, and y direction. They're all degenerate among each other, and basically in the spaces of the classical ground state, they are also connected. This is just another example where I took all signs of interaction antiferromagnetic, but the story is the same. So my ladders are now antiferromagnetic, and basically I can flip one of the ladders or all of them. So classical state we studied by classical Monte Carlo. So at high temperature, what we see all this. So this is the structure factor obtained from classical Monte Carlo, and we see that at high temperature, all these lines are present, and basically what happens is below certain temperature, which we call nematic temperature, only one direction is chosen. So it's spontaneously chosen only one z ladders, x ladders, or y ladders, and basically you have nematic state. And of course, classically, you have, it's not a Kitaev liquid because it's a quantum state, but it's classically degenerate state, so you don't have even nematic order in the vicinity of p-type point. So basically here, this direction corresponds to K1 interaction, and this one, vertical direction, corresponds to K2 interaction, cosine and sine. Okay, so then we look to the quantum K1, K2 model, and here the long-range magnetic order is actually possible due to quantum nature of the space, and actually the sliding symmetry is simply absent in the for quantum spins. The simplest way one can see it is looking to the state, looking to this coupling perturbatively, and one can see that these ladders, they are not coupled to the nearest neighbor, but they are coupled to the like second ladder. And I will talk about this because it was similar calculation done by triangular lattice by George and by Adolfo Abela. I will comment on this later. So basically, in our case, we have three types of processes. It's the processes which involve only K2 interactions, the processes which involve K1 and K2 interactions, this green one, and probably you don't see, but this